do you think a data structure is? And I'm not teaching you kind of the academic versions of this stuff. This is more kind of like experience on the job and how to think about classes rather than, and data structures rather than kind of like, oh, how do we program them? How do we think about them? How do we think about developing them? How do we think about what's important about them? So with that, what do you think a data structure is?
Maybe a container for information or different ways to store information.
I like that. That is, you're on the right track. What does it provide us? What does it give us? A class, an object.
It gives us order.
It gives us order. That is definitely a true statement.
Consistent way to deal with the data, like kind of with a programming
Yes.
interface.
It's the way that I think about it is all of those things, but specifically as a template for information that I'm trying to hold, structure, contain, and pass around to different pieces. So it's a template and a kind of like a container where, have you ever seen those board games? Anybody play board games? And how you have these boxes that have different specific places for each piece or each type of piece. So they have like different places where you're supposed to put everything. That's kind of how I think about a class. I think about building it so that it has a specific place for every single piece of information that I expect it to have. And that way, when you pass it around, you've got kind of a contract for how that data is supposed to be structured, and each piece of the program knows exactly where to reach for that piece of information. I'm going to be stopping very, very often for questions, but I also want people to call out questions. So at this point, who has questions? It's okay to not have questions, but it's also okay to have questions. Okay, cool. So moving on from that, if you were to, why do you think it's important to have a data structure? What do you think is very important about it?
It can help you organize code and make it more maintainable.
Okay, yes. What else?
It's easier for me if I have a template and I'm going to give you something that I've coded for you to work with it.
Yes, that is nail head, pretty much. So when we work with what we create or what I create, so I work on server side, which is why kind of data structures, object-oriented program is very important for me. Because I hand the client, who is another developer, I hand them a library or I hand them some sort of form. I'm gonna silence that shit. I hand them a encompassed form that I want them to basically fill out and hand back to me. You know, specifically I hand them protobuf, but that's very complicated shit. So I hand them that form, they hand it back to me, but we're passing bytes around, you know, the network doesn't have any way to structure that. So if I don't know where in, like, what order that information is in, what structure that information takes, and if that isn't consistent between me and the client, then there's no way for us to communicate. It's like communicating a different language. What we're doing is we're setting the language for communication. And that's important because computers communicate in bytes, but we don't, you know? So moving on from that, if I were to, questions. I'm gonna stop like every 3 minutes. Okay, cool. So moving on from that, if I were to say, okay, well, you know, there's 8 billion people in the world, I think, somewhere around there. If I were to say, what's a data structure for a person? Come up with some ideas
DNA?
of what information. Well, yes, DNA. We're gonna not use DNA because that's literally like that literally is the universe's like data structure for a person. But kind of what are some pieces of information that would be important to hold?
Name,
So some of them can include name,
nationality.
age, height, nationality.
Okay. So name. I'm gonna real quick connect to my iPad so I can write. Okay. Name, age, height, nationality, right? Anything else?
Hair color, place of birth.
Okay. How about time of birth? What did you guys learn about a while back that would help us structure this?
Classes.
Classes, yeah. So we could encompass all of this in a class called what? Person? Okay. But do we really want to be like looking through 8 billion of these to figure out? What else can we use?
An object?
So a class is an object. So when you think about classes, class and object are usually pretty interchangeable, because the way you define an object, the way you create structure for an object is by defining a class. So every object that you use is actually been defined as a class somewhere. And you can find it, which is actually really cool. You can just like go through all of the like libraries that are existent on the web and like look at classes that other people have defined. And sometimes you find really cool like functions that you didn't realize were there. Anyway, it's a really good exercise, but a class and an object are interchangeable pretty much in terminology. Sorry, he's dragging around wood. So you guys learned about inheritance, right? Yes. So how can we use that to better structure things?
Like create underclasses of each one of these people, or like create like nationalities and group people by nationalities, or group people into various categories based on some bigger shared trait.
Yep, we can do that. So we have, okay. So bigger shared trait. What should those traits be?
You could start with nationality.
Okay, so let's nationality. What does this do for us?
This breaks 8 billion people down into what, like 100 and some odd different categories that we could more easily search through and filter our functions.
Yep. What else does it do? In terms of programming, in terms of computers.
abstract it.
It abstracts it.
And if this was like if this was in a table somewhere, allow me to like do math with like how many people of this nationality do I have?
So you're on the right track.
Efficiency?
Yes. Efficiency for.
Efficiency for searching through your objects.
And one other thing, actually. There's another piece of efficiency that we have to think about in data structures.
Adding data.
Adding data in what sense?
In one place.
What?
If you were to single down into like the more specific category.
Okay, but we have two resources, right? We have two resources pieces to think about. We have speed,
memory and
which is
processing.
memory and
Okay.
processing. Yes. So how does this help us with it optimize hardware? Yes, it optimizes hardware resources. So
I could have a table of just nationalities so that I don't have a bunch of people who have, you know, they're American or they're from the United States or they're this or they're that. I can have them all be consistently American or Japanese or whatever, and I'm not duplicating this data over and over and over and over again.
exactly. So that is one of the pieces that you have to think about in terms of data structures. Is actually probably one of the more important pieces of data structures that you have to think about is storage. When you get to your job, you're gonna be building these things that are like probably, I'm gonna say probably, you're gonna be working on a much different scale than you've worked at before. My proof of concept at my work is 50,000 records. So removing one of the things that I literally worked on was removing duplicate storage. And so removing that removed like gigabytes of memory. And you think about that in terms of like, how many people use an Apple product here? Probably a lot of you, right? So you think about that in terms of how many people use Apple products, and removing one piece of information, even if it's 4 bytes per person, is huge. The scale at which you work is going to determine what your priorities are in terms of optimizations, whether it's storage, whether it's latency, whether it's durability or stability. But this is a very important one to think about, is storage. What about, we can do nationality. What's another thing we can sort on?
Gender.
It's actually a really good one. And I realize I'm getting into like problematic PC things, but we're gonna just keep trucking here. What else?
I was gonna say Android versus Apple.
We can definitely sort on that. What's the problem with sorting on that?
It's not static.
I guess, yeah, any of these, right? It's not static. Kana, were you gonna say something?
Oh, I was just answering the question that it's not everyone falls into the bucket.
Ooh, that's also a really good one. And that's actually a problem with all of them, right? Not everyone falls into the bucket. Like the only thing we can actually sort people on is DNA because everything else is changeable. So pretending that we're working with some static stuff. What else can we sort on?
Birthplace?
Birthplace.
Age.
Yep.
So essentially, is the answer anything that we can think of?
Yes. Yes, it is. We can sort on anything that we want to sort on. We can sort on all of it at the same time, right? Because all of this stuff is repeatable information. But what will that do if we're sorting on age, name, right? And we have none of these here, and let's just say we just have an ID. What's now really hard to do?
Tie all those databases together or all those tables together.
Yeah, it's really hard now. We now have to work pretty hard to one sec, sneeze again.
It's a pretty extreme design decision where I say, hey, I'm going to make 6 calls to my database to get this information about this person instead of just one and grab the information real quick.
It is. What's it useful for? What type of use case would make that design decision? I've made that design decision. It
I guess
worked.
if we were only going to ask for like one thing at a time about different people each time, then it would make sense.
Yep. Or if we were storing a whole ton of people, but we only look people up once in a while. So in that case, an extra few milliseconds, because that's really what we're talking about here, isn't going to matter. In what case would you want the reverse? In what case would you want the person to be storing all of the information and to be only grouped on a few things? Or if we wanted to be able to quickly look people up, but we wanted to like have all the information but we wanted to very quickly find other information, what would be an option?
Yeah, you can group it all together if you're pulling the people and getting all of their information most of the time instead of bunching people. If you're looking to pull, 50 particular people and get all of their information, that's a lot easier.
Do we have to stop bunching people if we store all of their information?
No.
No, we don't. We could sacrifice, storage for efficiency, right? What are we doing in that case?
Probably improving the user experience.
It depends on what the user is looking for, right?
Yeah, I'm thinking about like Facebook, where, if I've got all these posts on my page, I'm only scrolling through maybe hundreds, if every single time it needs to look at a post, it has to go out and find the user's name and then come back and then all this. That's a situation where I'm like, hey, I don't want this to take a second to load. My internet connection is slow because I'm walking down the street.
Yes, definitely. I could tell you how Facebook does that, but it's a little complicated. They do it by loading a certain amount per page.
I realize that, but
yeah,
still,
no,
it was
but
like
I
the
get what
use case I
you're
can think of.
saying. Yeah, is trying to so that use case it wouldn't be good. What's a use case where so for example, the DMV, right? How often do you go to the DMV?
Never if I can avoid it.
Yeah, never if you can avoid it. They don't ever need to look you up. They need to have you in storage though. So they don't need a fast lookup. but they need to store every single person in the US in storage. They're probably gonna do a single list, not have any of that grouping, and just be like, I'll look a person up. It'll take 2 minutes, but screw it. They only look me up once, you know? So there are use cases for each one. And what I'm trying to teach you is kind of there's, someone just messaged, would be counted their God. That's true. That's true. But there are use cases for everything, and locking yourself into one definition of efficiency isn't kind of useful or accurate. And I see that coming out of a lot of schools. So you guys are getting a heads up on most university educations by thinking about multiple different definitions of efficiency. So
May I ask you a quick question?
yes.
Just to make sure my head's clear on how we're talking about this. It's not that we still have to store all this information somewhere. It's just a question of which pieces we store where. Is that like, do we store all of it in one giant list, or do we just have multiple lists kind of separated out?
Well, here's a question for you. So if we have right? What she brought. Well, given that most of you were probably in the military, I guarantee you your social security is everywhere. So I'm pretty sure locking that shit up isn't gonna help. So if we do this, right, and we've got ID, let's say that's 8 bytes. ID, and then we just go down the line, right? And go down the line. As opposed to, so there are different ways, right? So how do you think that so we're storing the IDs multiple times, right? How big do you think, and this is getting into kind of like size of structure, but how big do you think storing an age is, or a place, or a gender? Like, what do you think that size is?
I mean, it could be under 100. You know, we could look at, there's no one over the age of 200 or something like that, and then only use that amount of bytes.
But what about historically? What if we want to store
dead people?
Yeah.
Okay, you got me there.
Right? What about places? There are so many places in the world, right? Depends on how we want to narrow them down. It's not that many genders, even if you add in all of the new ones. Names, you know, how big are names? You can't, you know, enum that. It's a string, so it's significant amount of memory, right? Clearly you've not been to India. There are, or the Latin American names, which can go on for like 2 minutes, you know, where we add on all of our family names. those get long. So you're thinking about storing huge strings. And even if you unduplicate them a couple times, it still reduces significant data if you, over the course of kind of like millions of entries. So taking that into account, now let's think about what size do you think a person, if we stored all of the information in one thing, what size do you think that person's ID or class would be, right?
So in your other data structure, it was like, if you're storing an ID with every single one of those slots, isn't it, what do they call it? It's like exponentially growing every single time you add a person. So because it's creating 8 bytes for every single category that it fits in. But if you put it all together as one, it's kind of just growing by like a fixed rate, because each person is going to have a set amount of data for each person object.
Not necessarily. Not necessarily is it a set amount of data. But also if you group by a certain number of things, like I think name is probably the biggest one. But if we have one name and we have 8 bytes, and we dedupe name, we've got, let's say a name is 16 bytes. Let's just be very generous and say it's a really short name. Then we're cutting, and like for the name Muhammad, how many people are named Muhammad or Maria or Jason or whatever? We're cutting that down by almost half. Oh, okay. So we're cutting that by half, so we're cutting it in half. And on the scale at which we're looking at, it's actually pretty significant. If we were storing like 30 names, don't do it. Like that would be not that smart, but the storage is actually pretty significant. So whatever you do to kind of reduce the size. Now, let's say gender, and maybe you could store a single byte for gender because it's a or two bits probably. You could store it in bits. So you're doing, sorry, I'm getting off. They told me to stop like going into like complicated stuff, but if you did an enum for gender, that's probably where you would say like it's not worth storing the extra 8 bytes and it's not worth sorting on it. But I'd say name is probably worth it. Seth, thoughts? You're making a face.
No.
Okay. No, I like discussion. So like if you like challenge me on something, I'm totally like excited to discuss that. So my point is, it's important to pick and choose, and what I'm telling you is not necessarily like a rule of thumb. You're gonna face a ton of different circumstances in your career, and each one of those is going to require improvisation. So you're going to reach into your toolbox and say, okay, well, what am I thinking? What are my priorities here? And that's kind of what I'm trying to get you to think about. What are my priorities here? What do I have to work with? And what is the best way that I can think of to solve this problem, given all of the information that I know. And so I'm handing you a tool for your toolbox, basically, is how I like to think about it. And every time, yeah.
I do have a question. So this is really fascinating. And if you are actually working, like in your situation, is this a team? Would a team come together and sort of talk through this? Or is this something that they would sort of assign one person and the person would decide and code it out that way?
It depends on it depends on a lot of things. No one person does it. No one company does it the same. So it depends on your expertise. So the person's expertise, obviously. So it depends on the way that the company works. It depends on how much time each person has. So I've worked on a team of 12 people. I've worked on a team of 4 people. We were not doubling up on projects with 4 people. That was not happening. But on a team of 12, you know, sometimes we did. A lot of times we did. We tried to. And so if you're working alone, usually what happens is you'll come up with a proposal, and you'll come back and you'll say, this is my proposal for how to do this. What do people think? At the end of the day, and I literally just had this discussion with one of my mentees at Apple. At the end of the day, it's your decision if you're the one building it. Obviously, like, defer to your manager, please. But like, don't go to them and say, I heard it was my decision. Like, no, like, defer to your manager. But in the end of the day, kind of, if you're the one implementing it, it is your decision. But it's important to get the feedback and input from other people who are experienced, who are more experienced. So these are decisions that I make, and then I go to someone, and just like I'm doing here, I'll be like, hey, so what do you think? Does this make sense? I do that a lot, actually. But at the end of the day, it is my decision to make. Yeah.
Thanks.
Yeah, so like I said, I'm handing you tools for a toolbox that you use to build these objects. So when we build objects, one of the most important pieces to think about is testing. And I know no one likes to do it until you really actually realize how important it is. And then you're going to be like, testing. I guarantee you that is going to happen. Like, there's going to be a time in your life where you're going to be like, I really want to be doing testing. And not in terms of actually testing it, but in terms of creating tests. So if you're building a data structure, let's say we have, why is this not working? I think my pencil died. I'm gonna be,
Oh yeah, how much complexity does that add to tests where you go, yeah, here's a table, or here's a data model and a class, a table, and I need to test that this object gets created correctly, and it's got to pull in data from 17 different places. Okay, now just go ahead and test it. And that's going to add a lot.
I'm going to show you a way to plan out tests that I learned actually from my manager back 5 years ago. And it's probably the best hack for testing. But you're going to see that actually reduces sometimes the amount of testing that you have to do, or the complexity of the tests that you have to write. Because what you have to test is the path through the data structure. You don't have to, you're testing different paths through the code. You're not necessarily testing this specific thing. You're testing a path through the code. And if you think about it like that, it actually makes a lot of sense how to come up with the tests that you need to develop. So let's say we have person has an ID, a age, a place of birth, maybe a height, right? Let's say that this is our structure for a person. What do we think? Let's say with these each have getters and setters, right? Okay, and you get the idea. What do we have to test?
You would need to, for if given this, you'd be like, hey, I'm gonna set my age, and I'm gonna try giving it a string and see what happens.
Okay. So let's say we're testing type and correct put. In fact, damn it. Well, whatever.
Talk to an Apple engineer about that.
That's Zoom. Just want to say that's not Apple. So for the age, for the getter, we're testing correct input. We're testing incorrect input. What else? Is that it?
Kind of like security flaws, probably.
No, we're gonna skip those for now.
All right.
I mean, that could be covered under this, right? Correct and input, correct input. I guess we could do, you know, invalid input. What's the difference between incorrect and invalid?
Invalid might be like a negative number for age.
Yes. What would be an example of incorrect input?
Birthday. I mean, the word birthday.
Yes, a different type, right?
Right. Yeah.
So like a string for an int or a string for a long. Versus an invalid input would imply that we're doing validation on what the value of the input is. Slight tangent there, but very important. So we've got 3 tests, right? That follow. Oh, that's not very thick. So we've got 3 tests. We've got 1, 2, 3. You see that diagram? How that's doing that? What I do when I'm testing is I literally go to whiteboard and I write all this out. And I check off these little things as I test them. It is probably the most complete, like easiest way I have found to do testing of a data structure or even a program. If you're creating an API, you look at the paths. You look at the paths and the options and what the options are for how you're following the path through the code. Does that make sense?
Yeah. So you're saying, so even if that was set in another table somewhere, that doesn't matter. Just break it down and follow the path and stop worrying and don't worry so much about. It's not going to be complex if you've broken it down to. No, it's okay. We're just doing this one test and that's all we're worried about.
Yeah, we're testing one path. Now, obviously you want to like do this for each. So if you have a table, this is specifically for the person. Now, if you have a table,
like talking about like the example where, you know, if I'm setting this person's name to an ID, and you know, because that's equivalent to Kelsey off on another table somewhere, you know, having to tie those together. I think about like mocks and everything's mocking, and I haven't done much of that.
I mean, we're talking unit tests here. So we're gonna not do functional tests. We're gonna do unit tests and just like, you know, imagine that all of this is hobbled together and you can create these and you've created these classes and you're just defining them. So if I was doing age, this just holds a bunch of IDs, right? You don't need to really, you can separate the testing because the only functionality for this, it doesn't need to have context. The functionality for this is specifically that age, like that this is a table that sorts the IDs. One sec, that is going to keep running. That is a landline phone. Okay, sorry about that. The perks of living in the country are that we don't have cell phone service. So literally this is just a like, you don't need to know that that ID points to a person. You just need to know that it is an ID that is returned by the table. You can test these in, you can test these in like in isolation because they're isolated data structures. If you get into kind of like trying to think how the whole thing works together, you're going to drive yourself in circles and be a headache. Test isolated portions of it, and you'll find that you're testing the whole thing. So this is actually really easy, just 2 tests. You know, because I'm guarantee you're probably using the same data structure for age, height, place, right? It's all a table. It's all the same table. So you don't really need to test that they work together because you know one of them works. So they all work. Does that make sense?
Makes sense, yeah.
Yeah. Okay. So I don't know how to stop sharing. Oh. Okay. So how do people feel about doing this? Okay, any questions? Is anybody lost? Because I can see how people would be. Any questions at all? There's a sledgehammer. Okay. I keep thinking that Duncan has his hand up. Because it's like,
no, just drowning over here. It's all good.
Okay, cool. Okay, so do people want to take 5 minutes and kind of try to come up with kind of a class and a few tests on their own, or do they want to go through it together? Kind of want to, or do they want to do a practical exercise, or do they want to continue on something else? All of those are options, and I want to kind of cater.
Sophia, can you talk a little bit more about like I would imagine that like everybody else is kind of like super new here, and you've had 6 years in the field. Can you talk about kind of like your first introduction to data structures and the first implementations that you used on them when you got to your workspace, and like the first time that you really had to use them, and some common errors that you had and some common like missteps that we'll probably make and that we could probably avoid?
Testing.
Oh,
I'm gonna tell you testing. Like, the reason I say that you're going to fall in love with testing is because you will make mistakes that could have been caught with a simple test. I spent an entire month once because I put a space at the end of a string and it was invisible, but it meant that that it didn't match. And so I spent an entire month trying to debug what I thought was a very complex problem, when in fact it was something, it was a mistype of the keyboard. And so I cannot emphasize enough that testing will save you years of your life, and that it is your best friend. In terms of kind of like how like some of the first data structures I used, I mean, it's hard because they're everywhere. So data structures are kind of like the fundamentals upon which like programming languages are built. And you see them in every single programming language, whether it's Python or Java or C, or they all have strings. That's a data structure. They all have maps, they all have dictionaries, they all have integers, they all have all these different standard objects, and each one is defined as a data structure in a public library that someone has written somewhere. So data structures are a fundamental piece of any type of programming. Even if it's JavaScript, you know, you still have objects. And if you're programming with objects, you're programming with data structures. One of the things that, so I watched some of your previous lectures, kind of trying to get a feel for where you guys are. And someone said the difference between like a software developer and a good software developer is kind of how they think about the problems. I would say that's the difference between a programmer and a developer. So a programmer knows how to program. A developer knows how to think about solving the problems that they're handed. So you give a programmer a task, they can hack out that task if you give them direction. A developer comes up with the tasks. They think about the tasks. They come up with those tasks that they need to do. And so that is where you should be aiming to be. Anyone can learn to program. What you're trying to learn is how to think about it. So, yeah.
What are some of the resources that you use to kind of guide you into becoming a developer then? Because a lot of us don't have experience with interacting with databases at all, like data structures. We've, you know, I can deal with a dictionary, I can deal with objects, I can deal with lists, strings, but like stepping up the game to actual data structures, it's something brand new to us.
Yeah. So one of the things, so I taught my husband to code. And one of the things that I used to teach him kind of data structures and object-oriented programming was he had this favorite game, Gloomhaven, and I told him to code it and build it. And if you think about kind of the structure of a game, right? If you think about the structure of kind of each character, and then you build the character, and then you kind of like revamp it consistently, it's actually a really good learning tool. I love Geeks for Geeks. And I, even as a senior engineer, I'm on there relatively frequently, less frequently now than I was like 6 years ago, but I still go to them. I love Stack Overflow. I love all these places, but really the way that you're going to learn it is by doing. And find something that you enjoy and try to translate it to kind of a program. In this case, you know, something with structure, like a video game or a board game or something that provides you that structure, and try to code that structure into classes, you know, and try to build that structure. That's kind of the best advice I can give you. You have the tool set. Like, I watched the videos, you have the tool set to be able to do that. It's just kind of translating that to the next step, to using those tools to do it. And yeah, one of the things that is a common misconception is that we expect you to be ready when you join a company. We don't. You're an investment. We are investing in you, hoping that we can teach you to the point that where maybe in 6-7 months you will be a productive member of the team. We don't expect you to be producing content right away, because even university graduates, even PhD graduates, honestly, they're harder to teach because they're already so set in their ways. But
that's very true, especially physics PhDs, because they think they know the fundamental truths of the universe, so they know every truth. Anyway, sorry.
Yeah, no, you're totally right. Because they've been trained that they know, that they can research, that they have these answers. You don't have the answers. You're not
a
gonna
doctor.
have the
Don't forget
answers.
that. They're a doctor. It's a joke.
Yeah, no, I know. Yes. But they, like, I mean, this isn't about that. You've been trained in a way of thinking that is very useful to solving your homework problems, you know, which is a problem that has boundaries. In the workforce, you're not going to have those boundaries. You're not going to have those guide rails. The problems aren't to solve within the guide rails. They're to put the guide rails, to figure out where the guide rails are. There are going to be so many different ways to solve things, and your kind of task isn't necessarily to solve the problem, because other people have solved the problem. Every problem is pretty much solved. You know, it's to figure out which solution is best. I don't spend as much time solving problem, like I spend a lot of time coding and implementing, but I don't necessarily spend time really, well, I do, because for the first few years of my career, I didn't spend time solving the problem. I didn't spend time, like, it was already solved on Stack Overflow. I could go to Stack Overflow, be like, how do I do this? And there would come up like 20 answers. My job was to figure out what piece of each answer was right, or was the best one for what we were trying to do, and where those guide rails were. So right now, what you're learning is more how to look at a problem, how to recognize the solutions, how to recognize what's like the differences between them. Okay. So we've been at it an hour. I'm gonna give people a break, if that's okay with Tom.
Oh yeah.
And like a 5-minute break, probably, if that sounds.
That works.
Okay. And then we'll come back and we'll implement some of what we were just doing.
Sweet. Or yeah, be back at 11:03 Central Time, and we'll go jump into implementing it.
Sweet. So I just want to point out that while we were on that tiny little break, I was on Geeks for Geeks refreshing my Python knowledge. So you'll find that like when you're working, there's so much to hold in your brain that it's impossible. And so one of the best things that you can do is have a knowledge of where to find the resources and the ability to quickly absorb them. So like I'm very efficient at programming with Python, but it's been a while. So I know how to look at, like I can look at a sample program and be like, okay, refresh my knowledge. I know how to program in Python again. You know, it's like that trigger. And you'll kind of like develop that as you kind of gain experience. So anyway, small tangent over. Okay, so can everyone see that? Is that too small? Sorry, okay, cool. Did a little Python project. So let's say we want to create a class person. Okay, so what did we say was in there? I already forgot. It was, one sec.
Nationality, gender.
Yes. Sorry, I somehow lost the window. Okay. There we go. Gender. -1. Why did I set it to -1?
You're going to store it as a, that's like, it's not set right now. And then you might use 1 for one gender and 2 for another and 3 for another and 4.
Yep. But why -1? Why not 0?
-1 is out of range. So it's kind of like a signal that it's not like a valid answer.
Yes. -1 is usually kind of accepted as the like, this isn't set thing. And or this isn't defined, or especially when you're working with kind of enumerations, or kind of setting a value for each, you know, for a certain definition. So usually -1 is kind of the one you want to reserve as the this isn't a thing. What else? We had age, right? So let's add age equals 0 because, or let's do age equals -1. That's also something. Age, height. No one's gonna have 0 height, right? I guess they could. So we set it as -1. Okay. So what else? What else did we have for this?
Date of birth.
We could do that. Data. Okay. What do we want to do for each of these?
Hey, Sophia, I have a question. Can you explain again why you would have it equal to, like, gender equal to -1, and not like none, or maybe just an empty string?
So you can have it equal to none, but the issue that you possibly might come up with that is that you might get a null pointer exception if you try to access it before it's set. So one of the things that I like to do is kind of set it to a correct input that is defined as invalid. So let's just say I was doing, I'm just going to create a very question 2, and then we kind of can go on. -1 is invalid, or I could do, but that way I have a definition for it. I have a value for it. And it's not like if I go over here, person, gender, let's say I had a deaf. Sorry. Let's say I had that person.get gender. Oh, God. Okay.
Just use a class in parentheses.
What?
Is capital just person?
Nice. Thank you. I forgot that I capitalized that. Let's say I did that. And then I tried to do that in pretty much any other language would cause a null pointer exception if it were none. Or that's going to cause a problem. Let's say I'm trying to manipulate it, or with age, let's say I was trying to find out how old I was going to be in a year, that causes a problem when you're trying to work with it. Let's say it's undefined. So it's a design decision that you can make of, do you want it to throw an exception? Do you want it to be invalid? Do you want it to be wrong for the person? Most of the time, and I say most of the time because it's not every case, you don't want to be throwing exceptions, especially exceptions that aren't planned. So like if I did, if self.gender throw, is that it? Except, whatever. If I threw an exception here, I don't know what the syntax is. I forgot syntax, but I don't work in Python very often, if you couldn't tell. But I can throw an exception that I actually want to throw. And so, let's say, again, this is kind of gets into like planning and testing, but let's say like, if I defined this as none, like I could definitely do none, but it's just kind of like a safety thing. It's like kind of a safer way to do that. So if someone did get kind of access to this or figured it out or did something like that, you'd be able to, kind of say it's not going to throw an exception. It'll produce the wrong error. So the other thing about that is usually when you're coding stuff like this, you're coding it as a continuously running program. What happens when a continuously running program throws an exception?
Stops unless it's caught.
exactly. So that program may be servicing, at least in my line of work, that program may be servicing 10,000 requests per minute or per second. You know, if I throw an exception, all of those requests are done until the program can restart. If I return a bad answer, only one of those requests is inconvenienced. So it's kind of like one of those kind of trade-off things of like how you think about it. There isn't a right answer. It may be in your benefit to put none and throw an exception and stuff like that. But in a lot of circumstances, it's safer to kind of just return a bad value.
Thank you, Sophia.
Yeah, that was a great question. Where were we with that? Okay, so we have okay. What am I missing?
Your setters?
Yes, that was what I was looking for. Just seeing if
Sophia,
anybody's paying attention. That's fine.
Sophia, for your talking back about tests, if you have a getter that doesn't have any logic, do you generally still create tests for those non-logic pieces?
Yes.
Cool.
Because what can happen?
I suppose if you don't have a valid guard inside a setter, you could get bad information in, and then if you're not checking for valid type when you're returning it, you could, be doing that type of thing.
Think about what happens when you're on a team.
Someone changes the code.
Yes. Someone changes the code and they do something differently. And if you don't have that, so tests aren't just about testing the code. They're also about defining expected functionality. And so one of the best pieces of test-driven development is that you are defining that functionality before, you're defining it before it exists. And so not only do you have something to work with, do you have like kind of like guardrails to work within, but you also have a piece of a contract to hand to the client or whoever you're working with, who can then say, okay, well, I know what to expect. I know what it's going to take. I know I have example code. I can work as well. I don't have to wait for this person to finish. So they have something to work within as well. So tests aren't just about testing, but it's also about kind of defining expectations.
That makes a lot of sense. Thank you. Quick follow-on question there. For your setters, do you generally put like your guards inside the setter, like the functionality to validate inside a setter? Is that where it makes most sense? Or is it more appropriate to have it like at an interface level that's actually getting the information to have those guards? Or I'm just curious, like, I don't even know if this question makes any sense, but
it does. What do you think?
I feel like it makes sense to have it at the setter level, because I feel like that's going along with the information where you would, it's at the lowest level where it makes sense. Like the information belongs to the person in this case, right? So I want to make sure at the person level, I'm validating that the information's right. The information might not, live with wherever the interface is. I don't know.
Can you trust where you're getting the information from?
That's a good point.
Why not both?
Yes, exactly. exactly. Normally, actually, it ends up in both. The important thing is that you don't assume that that the information that's being passed to you is correct. And when I say you, I mean the class, the program, when I say, when I speak as a like, oh, I can't assume this, I'm speaking as kind of like the program itself. I'm saying, well, I don't know where this came from, so I'm going to check it. Because like with the tests, you don't really know how this is changing. You don't know where it's being used. So I normally do both, actually. But what is the problem with doing both of them?
Duplicate code.
More than that. So duplicate code, but you can mitigate that by having validation functions. What's the problem with doing it in both places?
Taking up more CPU cycles.
Yep. Validation is actually really heavy. It's one of the heaviest pieces of coding, actually. So if you're validating things, usually you're creating matchers, you're, checking, you're performing a lot of actions, especially if you're validating a string. So it's actually pretty costly to do. And doing it twice is not usually good. What's another way that we can not do it twice? We can have a tag, right? A validation tag. It's getting into more authentication and security. But if we validate it and we have, say, a wrapper class or a validation tag or some sort of way to indicate it's already been checked, we won't have to check it again.
I see. So it becomes like a piece of metadata that goes along with the data that says,
Yeah.
hey, I've been validated.
Yeah. Or any other way you want to do it, really. You could have a wrapper class of, class validated gender, class validated age. So you could do that, or you could have a class validated tag, and just tack that on to, say, here where you have a validated equals none. That's where you would want a none, because you definitely want to break if you have an invalid. If you have unvalidated stuff, because that's a security issue and you have personal information here. But so these would be more to things to test. What's the issue with those? Like, you see where I'm going is you can go down rabbit holes with all of this, trying to make everything perfect. The thing that you have to consider is nothing's going to be perfect. It's not going to be the ideal, absolutely perfect thing. You have to consider what your priorities are and how to go kind of in order of them. Long-winded answer to the, you can validate wherever the fuck you want.
Thanks a lot. I appreciate it.
So
The proper military answer.
Oh God. Okay. Okay. So what do we want to validate here?
That it's one of our possible values.
How do we validate that in a single? So we have a class right here, right?
Yeah, I would ask the gender class if it's a valid input.
Yep. So there are a few ways we can do that. What do I need to actually do to be able to do that?
I would define a maybe is valid function on gender, and then have the code there.
So that's one option. Yep. What's another option?
You can create a list and put all of the gender things there and ask if this gender value in the list.
Well, I actually that was one I didn't think of. Okay, so we can ask whether it contains there. What else? We can just check if it's of a class gender, right? We can make them give us a gender class. So we can do if if does anyone know the is type? Is that
Is instance.
Instance.
It's just is instance.
Is instance.
Yeah.
Ah, there we go. Okay. Is instance. Thank you. Right? I'm going to say you have to provide us with a gender class. I don't care how you do it. You just have to give us this. Sorry.
Oh yeah, and
I do that.
No, that like then when gender is created, it does its own validation when it's being created.
Exactly. And that way, it's not our problem. They have to figure out how to. I think that's right. Whatever.
Sounds really aggressive.
What?
It sounds really aggressive. Like, yeah, good luck with my documentation.
Yeah, no, this is what I mean when I say as an engineer, you just kind of gotta like take no shit. Like you're just because well, so if you try to coddle the client, then you just end up in this kind of like whirlpool. But here where they have to validate it for themselves, then you're pushing the definition onto them. So they have to define it as well. So when you have something that's like this, where the client is giving you a value or a definition, if they're coming up with that definition, they should be the ones to define it, right? They should be the ones to define the valid input, because they're the ones who are actually creating the input. So what you really want to do is have a property that's exactly what I forget who it was said about that list, is define that as a property for the client to be able to define as a valid input. And so then you can have a gender that says, takes in that property on a knit. definite, right? And just does, you know, if and you throw self right? And that way it's their problem. It's not yours. If they're the one passing value, they should be the one determining valid input for that value. Obviously, you know, you can put checks in here, making sure it's not like negative or a string or whatever, but, and you can define that this has to be, you know, a list of integers, but they should be defining what those integers are. Does that make sense?
Oh yeah, absolutely. And then it's not like you're going to get some gender, like ill-formed gender in that case. So it's going to be
exactly. Exactly. So you're defining the goalposts. They have to put it down in the place where they want them. So that's kind of like probably if I were writing this in practical terms, this is probably how I would go about it, because I don't want to mess with having to change, because clients change their mind and it is infuriating. And so if you hard code this kind of thing, then every time they change their mind, every time there's a new gender that they want to add, a new category that they want to add, you have to go in and you have to change the code and you have to change the validation, and then you have to test it, and then you have to redeploy it, and then you have to like make sure that it gets in, and then you have to do QA, and then you have to like for one integer. If you define it as a property, you don't have to do anything. Be lazy. It produces good code.
I'm sorry, Sophia, can you talk about defining it as a property just a little bit? So
yes.
when you say that, you're talking about in that gender on line 8, the gender list, you're saying all they need to do is just change the integer in there, and then that kind of fixes it?
Yeah, so if you're taking it in from a hot property, for example, if you're taking it in from property, so property, how many people know what properties are? Who doesn't know what properties are?
I could use an explanation.
Okay, cool. Because I realized I said that word and I didn't think about the fact that it's probably not been covered. So properties are like global variables. So they're things that are defined and that are taken in from the system. So from the computer, they're defined in the environment. So they're not defined within the program. They're defined within kind of the environment the program is running on. So, max int, right? Do we have a max int in here? Either way, who knows what the max int is? Okay, so the max, so
2.1 billion.
Oh no, I was saying who knows that it's a thing. Yeah, no, I don't even know what the max int is. Are you kidding? I think it's like 2 to the 16th. But no, so the max int is a property. It's a global property, and it's defined by system properties, which is what your computer defines as the maximum value for an integer, right? You can change it. I wouldn't recommend it because you're gonna come up with all sorts of problems, but you can definitely change it. Or let me see. It's something that the client defines or you define, and the system kind of uses that definition that's provided to it, rather than kind of like having it hard coded here. Trying to think of a better way to explain it. It's something that's provided by the client in another class. And they give you, okay, I got it. So, okay, so let's say that you have a recipe, right? And the recipe says, okay, 2 cups of this, 3 cups of this, 1 teaspoon of this. How do you know what a teaspoon is? It's not told to you by the recipe, right? The recipe has no definition of a teaspoon. It's, you have a separate piece that you're bringing to the table that provides the amount of a teaspoon. It provides the definition of a teaspoon. You could get another spoon and be like, I changed that definition. The recipe won't work, but it's not their fault, it's your fault. Because you changed the property, you changed what you're defining as those measurements. That's kind of what a property is, where, you know, I'm providing this recipe for what is valid, for what, you know, I am looking for, and the client's handing me the teaspoon, you know, saying this is the amount that I want, or these are the measurements, like 1 cup, 1 thing, because they all come together, right? That's your list. That's your list of values. That's your properties. Was that a good explanation? Or are you now more confused than ever?
Oh, it definitely makes more sense to me now. It's just kind of like a global variable that exists on outside of your program, at least
Yes.
one level up outside of the function that you're working in.
Yes, exactly. Kind of like arguments that are provided to you. But anyway, that's kind of how I would do it, because you want to push as much, like if things can go wrong. If things can go wrong, one sec, I'm catching up on the chat real quick. Okay, wait, Python doesn't have a max int anymore?
I just looked it up there.
Okay, I love Geeks for Geeks. They're so great. They are legit like my favorite go-to.
Yeah, maybe on the OS import or the system import.
Oh, so that's exactly what it is when you're doing a sys dot, it's querying system properties. So it's querying your specific system for like sys.path, right? That's a property of your system. It's different per computer. So anyway, off on a tangent, and I promised no tangents. Why is it? Okay, that's annoying. Okay, my computer seems to be weird and not letting me type in the chat window. Okay, so we are short on time. Okay, I really want to get to some of these tests. So what did we agree were the tests that we're looking at?
Valid, invalid, correct, and incorrect.
Okay, so how do I test that? Test. How do I name them? That's an even better question. What do I name it?
Should be correct gender or should be gender class.
Okay, so I'm going to teach you something. You always want to kind of like say what it's doing. So in this case, test get gender or test set gender rejects string. That's what I would do. Like testing names can be really long. Like there's no limit to how long testing names can be. I've had a name for a test that's gone like 60 characters. They can be really long because they're kind of the definition of what it's doing. Because when they fail, what you want to see is what broke. And what you see is the name of the test. It's, oh, test set gender rejects string failed. Okay, well, I know what's wrong with the program then. It's a very easy, quick debugging. So if I were doing this here, I do me equals person dot init. Okay, and then me dot set gender. Hello. So here you'd want to do a try. I'm just, in this case, I'd say false is it failed and true is it passed. What is this showing me?
I guess it shows if you were able to set gender and execute that function from start to finish or not.
Yep. Well, if you were able to execute it from start to finish, then that's wrong, right? So what else? What's the next one?
Test.
What else do we need to? What?
Test set gender accept string.
Accepts what?
String.
Do we want it to accept a string?
If it is a correct one, no.
What are we checking in check gender?
Would it be integer?
Or yeah, integer, sorry.
Integer? Or
It's
something
a
else.
gender object.
A gender object. Because remember, we said we weren't going to actually do the validation. We were going to make them pass as a gender object. So me person dot init. Why am I creating a new one every single time?
You're trying to do the test in isolation from the other test.
Yep, that's exactly. did not want to do that. Nope. How is that being an issue? I don't like that. Gender.init. One, two, and one. So gender, new gender, right? Then it failed. It passed. Okay. So what else do we need to test? What are we assuming in these tests? This is a good question to ask yourself, is what are we assuming?
That a gender object exists.
We're assuming that it works correctly. Right? So what do we need to test?
Test can create gender object.
Yep. I really like that test name. Okay. You see how this kind of like snowballs and you end up with all of these different tests, but what is this? Like, if you read these test names, if that's all you read, what do you already know about the program?
How it should function.
How it should function. These tell you exactly what set gender accepts. It tells you that that you can create a gender object. It tells you if I wanted to do def test gender object rejects a string for genders list, right? It tells you that it needs a genders list. Def test gender object rejects gender value not in gender list. It tells you that the gender object gender value needs to be in the gender list. Def test gender object rejects gender list of non-ints. It tells you that that needs to be an integer list. You see how I'm creating documentation through testing. So any questions?
I very much drank the TDD Kool-Aid. I enjoy it, but one thing I struggle with at times is wanting to test a feature, but not knowing how to compose the test in a manner that appropriately tests the feature. And I find myself in those situations kind of like maybe straying from the discipline. And I suppose there's probably no good answer for this, but I'm just wondering, like, if you ever find yourself in those situations where like, I don't know how to create the test. Like, I feel like I'll spend a lot of time trying to research that. And
usually that means your test is too big.
I see.
Usually TDD works when your tests are tiny. So these tests are a few lines of code. when you're testing a very small thing, one thing at a time. And that's why I was saying, like, draw out that, because you can always draw a program. There's always a way to draw a program. Draw it out, find the paths through the program. Each path, each single path should be a test. Now, obviously there are, there are pieces, but don't try to test the program in its entirety. Don't try to test, the getter and the setter all at the same time. Like, obviously you have to test the getter, you have to set it to be able to get it, but work in those tiny little chunks. If you assume that things that you've previously tested are correct, it reduces the complexity of the test that you're trying to create. So start small and work out. Start from the very, very, very smallest piece. But usually that means if you're finding yourself kind of like being like, I don't know how to do this, I don't know, usually like take it and say, what is the smallest thing? Like, usually that means your tests are too big.
Awesome. Thank you.
Anything else? Since we only have 10 minutes left, I'm gonna kind of leave you guys here and say we've reached a stopping point.